Thank you for that welcome. It's always challenging being the first speaker after lunch, but I do appreciate everyone that's here. As Manish said, Deepfield joined Nokia now about 4 months ago, though really the journey is much longer. We actually began working with then Alcatel-Lucent some 15 years earlier, developing joint security DDoS solutions. So it is really quite exciting for me, after some 15 years, to finally recognize the sort of realization and actually be part of Nokia. So I'm very excited today, and on behalf of myself and my team, to be able to tell you some of what we've been working on, but perhaps more importantly, tell you where we're going next. Before I talk about our current efforts, I think it's important to set the stage. And I really view both my own professional as well as the internet as a journey. The journey began way back when. My first job out of school was a backbone engineer on the then National Science Foundation Internet. One of my first jobs was to develop management and analytics software as the internet, the national internet in the US, transitioned from a speedy 1 megabit to a T3 45 megabit network. And it turns out, back in the early days of the internet, management was an afterthought. That's why they gave it to me. So I was tasked for developing and writing SMP monitors to build out, to monitor the network. And even back in the early 90s, it was a bear. SMP had scalability, reliability, even security problems. In fact, though I don't like to bring it up, and we're no longer webcasting, it turns out one of the first widespread denial of service attacks on the internet was me. One day I deployed some SMP code that just ran a few too many OIDs, a few too many polls, and ended up crashing the IBM ENSSs, taking out, give or take, about a third of the US internet. It was a very long night as I worked to bring up the T1 internet, was able to get it up by the morning. And it was an equally uncomfortable staff meeting the next day as we discussed it. Luckily, we just got 3 or 4 email. You know, the internet back in 1990 simply could go down, and you would only get several email. We also only did updates once a month and then once a week. So the frequency at which we added networks and other networks was also part of my responsibility. But those were the early days. So stay with me on this journey. Let's fast forward 10 more years. In 2000, I and now several of my management team at Deepfield started another company. We created what became the first commercially successful denial of service traffic engineering solution. It was a security solution that was not an afterthought, but was an add-on to the network, where people could now deploy DDoS gear across the peering edge, DDoS gear to be able to both block DDoS to mitigate, as well as an added benefit, provide traffic and engineering and visibility on the peering edge, and for the time, do it really quickly, which meant once a day. I should mention, by the way, in my first job with the NSFnet, it wasn't even security, it was an add-on. I mean, we didn't think who would ever attack the internet. And of course, that all became clear later. So while we were working on the last company and protecting the peering edge, it became clear the world was changing, and it was beginning to change quickly. Vast volumes of traffic were moving from peering to the metro, moving from thousands of individual servers to cloud to CDN. Literally, the topology of the network was changing, and certainly the market problems were changing, all of which led us to what became the vision for Deepfield. And the vision for Deepfield was a network where security is not an afterthought, but is part of the network, where telemetry is not something you add later, but you build into the network, where the intelligent network is driven by best-of-breed, big data analytics, being able to pull in data not just from a few routers, but all routers, interfaces, across the network at scale. It's about the ability to leverage what's become a growing breed of telemetry-capable routers. Routers that you, in fact, can get data from without the fear in the back of your mind, are you going to crash the backbone? And believe me, for many years, in fact, many of you may not know, but this is still a very legitimate concern of most service providers who limit the amount of S&P, the amount of telemetry coming out of their network for fear of disrupting the backbone. Can you leverage the network? Things like the FP4, real-time telemetry, telemetry across a range of statistics, and as Rudy and others will speak about after me, to implement policy across the network to have embedded security. And can we drive real-time efficiency and security use cases with Deepfield providing the intelligence, the analytics, interacting with NSP and SDN orchestration, and leveraging FP4 deployed throughout the network. Going back a bit, in 2005, I think when you would talk to providers about analytics, what they really meant was not how to improve QoE, not how do we make our customers happy, but in 2005 it was, well, how do I block all this peer-to-peer traffic? And so back in 2005, network management, network analytics became discovering peer-to-peer and deploying very expensive third-party chassis DPI on specific links throughout the DSLAM, throughout the cable network to actually block the traffic. Now, it turns out that a side benefit of deploying all of this DPI to block all of this peer-to-peer traffic is that this DPI gave you visibility. Really visibility for the first time into some of the performance and some of the applications of the network. Now, it didn't tell you about your entire network. It told you about where you had deployed that DPI. And providers liked that so much that then they deployed IPDR collectors and management collectors. And pretty soon, the service provider data center filled. I used to go on tours of the data centers and just be amazed by the amount of stuff in the racks, all with different UIs, all with different APIs, all different vendor logos. And all, it turns out, with someone in the service provider organization responsible for that particular box. And that's how we did networks, and that's how we did analytics in 2005. Of course, the challenge is the network is changing. In 2017, it turns out service providers care about performance. They care about quality. They care about what their customers are saying on social media and about their contracts with other content providers who pay them based on the quality of their data. The challenge is we've gone from a world where traffic comes from just through certain links and peering links to very dense interconnection through traffic that's now driven across peering, across transit, across CDN, that comes from the metro, comes from the peering. And it becomes quite challenging to understand not only what applications are in my network, but where the heck are they coming from, where is it going? And most providers, again, today have SNMP, which provides octets and packets. But can it answer complex questions about quality, performance, and security? And while many providers still have elements of DPI today, the real question that we're seeing in the market is what happens next? As we go from 10 to 40 to 100 gig, as Moore's law, or I learned from Basel observation now, changes the rate of the network, do we still see a world in which service providers, large content data centers, fill their racks with custom ASICs, custom chassis? Or is this technology that increasingly becomes embedded in the network and is not an afterthought, but is part of building the network? Well, of course, I'm a little biased being here today, but I will argue that I think custom ASIC, custom chassis, all the things we used to do in simpler, slower networks are really on the wrong side of Moore's law, if not the wrong side of the emerging internet history. It simply doesn't scale. And worse, all of this third-party kit doesn't perform nearly as well in a world where vast volumes of traffic are moving to SSL and encryption. The other problem providers are facing as they look at these racks and racks of third-party kit in their networks that all has different UI is how do they get a holistic, cohesive view of their network? Because business today, whether you're Amazon, whether you're FedEx, businesses are driven on data now. They're driven on how efficiently they can run their business, the visibility they have into their business. And dealing with 100 different silos simply does not meet today's market problem. Lastly, I think typically service providers could generate reports. At the NSFNet, we used to do one a year, where we describe all the traffic demands and matrices and what the network looked like. Typically, you could choose before doing a report once a year or having very limited, small, maybe S&P data that was far more timely. One of the themes of today, of course, is that you no longer have to choose. And some of the technology I'll speak about, Rudy and Sasha later, about how you can leverage some of the hardware technology, some of the Deepfield software technology to be able to have real-time analytics. So the hypotheticals. What if you could have visibility to every application, every service, every piece of infrastructure and CDN in your network? And what if you could ask really complex questions about this traffic? Not just how much traffic is on an interface for Hulu or for another OTT, but where did that traffic come from? What is the performance, latency, loss? Which routers did it go through? Which DSLAM? Which CMTS? Has it gone up? Has it gone down? What's changing? What if you could ask those types of questions? And what if you could do all of those questions in real time at scale across your entire network? And of course, these hypothetical questions, as it turns out, are not very hypothetical. Deepfield is deployed now across North America, now in Europe, covering a very large portion of North American subscribers, some 80–90% of subscribers, and deployed in some of the largest service providers in the world, collecting data across their infrastructure in production at scale today. So Deepfield. Deepfield is about, number one, ingesting data. Certainly it's about ingesting data from routers and switches and typical things in the network. But networks today are not just about routers and switches. Routers today are about everything else that goes into providing service to their enterprise and consumer and wholesale customers. It's about service APIs, performance APIs, DNS data, log events. Can you use ITF, EEE, other standard practices, other standards to collect all of this data in real time and collect it across the network? And indeed, Deepfield does and is doing today. But certainly the network is one component of the service provider business. The other component, of course, is the customer. It is customer care, it is billing, it is all of the other things that go into tracking performance and quality in the business side of the provider. So today, Deepfield also is engaged in collecting all of these other data sets in provider networks and combining them in real time. The third thing that we set out to do with Deepfield, in addition to being able to collect data about the network, about the business, was the internet. As the internet grows more and more complex and traffic comes across many more different paths, can we actually provide value and visibility into what is happening in the broader internet and how that traffic is flowing and how it's coming from? And I'll talk about what we call the genome, or essentially Google-like mapping of every IP, every IPv4, every IPv6 on the internet, and how we build that map in the next slide. But we combine all of these three data sets together in real time to what we call the Deepfield Core Platform. And the Deepfield Core Platform is software. It is a software platform that runs on Linux or runs on VMs in provider data centers, as well as we have some fully SaaS customers as well. It is horizontally scalable software, meaning if you need more capacity, just add more servers. And this provides really flexible ingestion of a wide variety of data types. It provides machine learning and intelligence across the data set and real-time APIs and analytics to drive applications. Now, Deepfield provides APIs where providers have written their own applications. These would include some of the largest CDN providers in the world, as well as some of our telecom providers. And Deepfield also uses this data to drive our own applications around cloud intelligence, traffic engineering, around service assurance and service intelligence, about quality of traffic, and most recently about security, which you'll hear more about today as well. So these are the data sets that Deepfield is collecting today in production. And to provide a little more discussion of Genome, we set out to really understand, for all of these millions and hundreds of millions of IPs in the internet, for all these complex video services that use Amazon or Google Cloud, how are people building these services at any given time, at any given day? How are different IPs in Amazon or Rackspace or Google Cloud being used? So we set out, it's now actually a patent. So we now have patent technology, as well as trademarked, that goes out and actually builds maps of the entire internet at scale, every day, all day. And the goal is, number one, to discover how all of these over-the-top and internet applications are being built, what are the endpoints, which IPs, who are the customers of Amazon, who are the customers of Google, all providing really rich visibility into the broader internet. We also use the same technology to understand within subscriber and consumer networks, what are these millions of IPs? Can you go out and identify all of the baby monitors that are internet exposed in the world, all of the IoT devices? And indeed, we also go out and build huge maps for that as well. And I'll explain coming up why these maps are so important, both for traffic engineering as well as for security. So we build all this map. We call it the Genome, as I said. And this map is downloaded to the software servers running within provider networks every about 15 minutes. And we combine that data with traffic in their network to provide visibility, not just about traffic within the enterprise or within the telecom, but visibility into where that traffic is going and where that traffic has come from. So let me make this a little more concrete with an example. We had one cable provider customer that started out at the top of the Netflix rankings that Basil and others mentioned earlier. And they were quite happy. This provider had done a massive investment into their physical, into their plant and their RF, building out their infrastructure. And they were quite happy with how well the network was architected and how well the network was run. And then, 1 month, the Netflix rankings came out. They went from the top 5 to 8th. Caused some concern. In the next month, when they dropped to 12th, and social media lit with what turned out to be some rather unkind comments about the provider, the board started to take notice and ask, we made this massive investment. Why are we in the bottom third of all providers in the US? And it turns out it's kind of a hard question to answer. You look at S&P, circuits are up. You look at capacity, they had capacity. You know, where was the problem? Netflix just told them that, just what they was measuring, and no, they couldn't see their secret algorithm for how they were measuring it. It was really their problem. So this provider came to us, deployed Deepfield. We began to collect data from all across their infrastructure. We began to identify the applications. And Deepfield really provides the ability to start to ask complex questions of, do I have a problem on the peering side? Do I need more capacity? Giving visibility not only into Netflix, but how that Netflix goes across the network. It's visibility not just on the peering edge, but on the consumer edge, on the last mile, understanding traffic through CMTS. And do they have a problem with an individual CMTS or a market or a service group? And it's also, increasingly, networks are not just about delivering bits, but about delivering content. Do they need additional CDN, OpenConnect, GGC, other caches within the network? So I'm very happy to say, within about a week of deploying all of this, they had their answer. And within 2 weeks, they had addressed the major issue, and they are now, today, safely back in the top 5. But Deepfield is not just about one time saving you from the ravages of social media and Twitter about your performance. Deepfield really is about, on a daily basis, being able to have the intelligence to understand when there are issues, not just how much Netflix do you have in your network, but over which CMTS. And when you do have an issue, by the way, these are all real graphs. So this is all real data, all real graphs from the product. But visibility in Netflix down to the CMTS. And even the ability to go one step further. The ability to ask when there is an outage, not just as circuit up or down, but how many users were affected by it? How many streams? How many people were watching Netflix? And again, all of this is being done in software at scale, leveraging, I'm going to get a drink actually, if you could. Oh, behind me. At scale in the network. Let's pour water. So let me just shift gears a little bit and talk about security. So I've spent 15 or 20 years of my professional career doing DDoS. And in addition to causing my own outages, back in 2003, we had the Great Slammer Worm, which really over a course of 6 weeks devastated huge parts of the internet, a Microsoft worm disrupting traffic, significant problem back in 2003. Since 2003, the internet has really spent billions on endpoint security and research to address all these end systems. And I'm quite proud of all the work that was done, because by the time you get to 2017, it's not 6 weeks, but you can have a worm that does even more damage in 6 hours. So clearly, we continue to have an issue where the world relies on endpoint security to address these threats. And the problem is even more problematic given the criticality of the internet. In fact, this even hits close to home. Back in 2003, my mother didn't notice. In 2017, banks go down. My mother calls me after disconnecting the power to all the computers in the house, asking if she was safe. I assured her she was. So with Deepfield, we're focused also on using the analytics and big data to be able to pull data across the network, to be able to not just protect the peering edge, but to be able to have the intelligence and the data to understand attacks coming from the subscriber edge, from the metro, where all the IoT and other devices, of course, reside. And really the days when you could just protect the peering edge, or security could be an afterthought to the network, are, of course, long gone. So with Deepfield, we're providing the scale and the analytics across a broader area of the network. We're focused on new detection algorithms. Detection algorithms to be able to detect new customer threats, to be able to detect degradation in customer, and to be able to integrate with different types of subscriber policy to do things like quarantine subscribers. So this is my last slide, and I will leave with just a couple of thoughts. Ultimately, businesses today, whether you're FedEx or Amazon or other large businesses or a telecom provider, are being driven by data. This is true of optimizing your supply chain, optimizing your performance, and it's certainly true from security. Security and understanding the attack in a massive data is really all about who has the best data, who has the best analytics to address false positives, false negatives. And with Deepfield, we've taken what we did some now 15 years ago and really leveraged the latest generation of computation, of machine learning, and applied it to modern networks. Very proud of what we've developed. We have, give or take, about 100x better scalability than anything we addressed in the past. We've gone from technologies that provide detection in minutes to real time. We've applied a whole range of new machine learning and topology algorithms to be able to address it. And finally, we've leveraged the work we've done with Cloud Genome. As Basil mentioned, earlier in 2016, we saw the massive Dyn attack with web DVRs and cameras attacking. The challenge for companies like Dyn and other people from DDoS attacks is when you're in the business, like Dyn was, of being a DDoS provider, how do you know which DDoS is legitimate and not legitimate? It all looks like DDoS to you. Again, it's all about data. Can you discriminate the attackers from the legitimate traffic? Wouldn't it be amazing if you could identify all the likely baby monitors, all the likely DVRs on the internet, and use this, and by the way, this is also a real trace, a map of what every IP address for a given day has on it, and use this as part of the filter. And of course, that's what we are doing. But I think the really important point I'll leave with as I introduce the following speakers is that having the data, having the analytics, having the intelligence is only half the story. Generating an alert about a DDoS, generating a pretty graph about dropping performance in a network is not nearly as compelling or valuable as being able to integrate with the Nokia platform FP4, as well as we're continuing, by the way, to support other vendors as well, but be able to do line speed, ubiquitous DDoS mitigation across the platform. Having all the intelligence about performance is not nearly as valuable if you're just reporting, but to be able to integrate with NSP and orchestration, SDN, and have real-time intelligence to drive performance gains in the network makes it significantly more compelling. So security, as I said, is not an afterthought. I think as we imagine the network, or reimagine the network, security, performance, telemetry, analytics are all an integral part of the next generation network. All set?